Okay, so this is just supplying a negative, and I've made a common rail here. So it's a common negative. The negatives I've labeled up the momentary switches. I put the appropriate DuPonts on. So they're all been tied to negative, and then I've labeled them up, and it took a little while just to check, beep, 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 beep. I've got it all continuous. So this one here says looper. Let's hold that like so. Oh, sorry, get that into view. Push that button. There we are, the looper's on and the looper's off. Good. Okay. This one here says mem stomp whatever. So that's the same as pushing this button on the left here. Let's give that a go. There we are. There we go. And there we are, the free cycle. This one here says setting. So that's the one on the right. There we are. Okay, so we can go setting and back. This one here says FX5. Sorry, get it under view. FX5. So when we push this, the number 5 should light up, I think. There we go. Oh, gold. This one says FX2. So let's push that, and number 2 should light up. There it goes. This one says FX3. So I push that, number 3 should light up. It does. This one says FX4. I push that, number 4. Yeah, FX1. I push that. Hang on. Oh, that one's not working. Why not? Have I got a loose wire? Which is why we test stuff. Okay, so FX1's not working in a minute. I've got to trace that back to work out why. What's this one down here? Rhythm. Yeah, there we are. So it's just FX1 that's not working in a minute. And that'll probably be a loose connection, because the actual, that'll be the loose connection. Yeah, so let's work on that. But anyway, it looks good. Okay, here's the latest mock-up. Just so this one should be the settings. Yeah. This one here should be the, sorry, that was the mem ink, whatever. This is the settings. Yeah. This should be the rhythm. Can we see that? Yep, it's gone onto rhythm. Push it again. Yep. This should be FX1. Give that a go. You should see the light move basically. Oops, it's falling out. Hang on. You should see the lights move. Number 1. Number 2. Number 3. Number 4. Number 5. That's it. It's all working. Good stuff. Okay, so we're at near the final stages. This was the matrix I described in an earlier video. The idea being you've got the rows with diodes to decouple and stop ghosting, and you've got the resistance coming down the columns, and you use 8 digital pins to control 16 inputs. And I debugged it. I thought I only had I had one row or column not working. In fact, it was this column not working, but it turns out when I plugged it into the Arduino, I had forgotten. You know, when you read the Arduino, you sort of read it, and I was out by 1 pin. Now I'm building this circuit here. So what this is a 74595 chip, and this is a serial in, parallel out, and it will daisy chain into the next one and the next one. So we have 3 of them together. That gives us 24 bits in total. Pin 16 goes to red, or 3.3 volts. And as does 10. I'm a bit colorblind, but I think that's a red. Then, of course, 16 and 10 go together, and 16 and 10 go together. The ground comes into 8 as per usual, but it also needs to go into pin 13, and then you cascade into pin 13, you cascade into pin 13. 14 is the data input, and the chip automatically pushes this out the back if it overflows into 9, so that becomes the next input of that chip, which overflows and becomes the next input of that chip, and then we end because we've got 24 bits. 15 is the D0, or the 0 pin coming out. 1 is the first bit, the second bit, the third, fourth, 7th bit. So I'm putting them together into a sequential line so I can take them out into the other processors. Oh yeah, what else? So you have the latch pin 12. That goes to an output pin, and then it needs to be connected to the 12 on the next one, and the 12 on the next one. And the 11 is the clock register, shift register clock. That's how you clock the data in. That needs to go to an Arduino pin and then cascade to its little mate in the next one. So you use 3 digital input pins to get 24 outputs. And this is what it looks like so far. So we've got 3 16 pin chips. There's a input going into pin 8 there. That goes to pin 8, it goes to pin 8, so that's the bottom ones. Then it cascades round into the pin 13. And then it jumps underneath to its little friend, pin 13, pin 13. Let's get a bit closer. Yep, so it goes to pin 13. This orange one, I think, is data 1. And so therefore, as that's the second pin in from the left. So at the end of this board here, the second pin from the left, the orange, is coming around and going into the 9th pin. And then second pin in from the left, the orange pin is going into, what, the 17th pin is? I don't really know. This is the bit 9 cascading to 14, 9 to 14. This is the clock, I think, number 12. So that's the latch pin. So the latch pin is going to its latch pin, going to its latch pin, and the shift register is going to its little friend, who is going to its little friend somewhere. Let's just follow that one. Yeah, the yellow one there. Is it yellow? Yep. And now I've just made a load of pieces to go in here. I've checked it for continuity. There was a slight problem, but that's because I haven't trimmed the bottom off. And for me, that soldering's not too bad. It's not brilliant. Oh, yeah. So you put a cut across there because you don't want the chip to talk across the pins. And you put a gully in there because you're going to take these outputs and put them sequential next to each other. Then I'm going to put 2 rows of headers. I think I'll put 1 male and 1 female on the bottom here. And this will allow me to either take the data directly out, or I have a second output which I can put into, say, LEDs rather, which can go to the actual above the switches, and when the microprocessor does some work and sends a switch, it will light that LED to show that it's sent an output or whatever. So that's the plan. I'll get on with a bit more. Just solder these other little bits. I've just cut them here. I made a little line to show me how long they should be. So I've just got to put them in. In fact, I'll put some in now. So that's what they look like when they're wired in. I'm just going to put a bit of tape over and hold them in place and solder them. So we got pin 1 goes to 15. So digital output 1 goes to 15, 2 goes to 1, 3 goes to 2, 4 goes to 3, 5 goes to 4, 6 goes to 5, 7 goes to 6, 8 goes to 7. Oh, look, it's in line with that. Well, not really, because we've got this break in the board, yeah? So it isn't touching. So that's what I'm about to do, and that should get, and then the final rail I got at the bottom. So let me get on with that and see how it works. Okay, so that's the finished soldering. That's some of the best soldering I've ever done, that stuff there. I realised that the solder I've got, I don't read Chinese very well, but the solder I've got doesn't really have much flux in it. But I put a little bit of the flux paste on it, and it really flows well, yeah? So now I've got to spray off a bit of alcohol to get rid of any flux, cut off some of these longer leads, check for continuity where there should be, and check for continuity where there shouldn't be. So now we've got the basic circuit. These orange things will go slightly further like that. The chips will go on top once I've tested it. You can test it without putting chips in. Then we've got a set of pins here and a set of pins there. We don't have to put anything if we don't get any outputs, or we put them in both. We can take those into the circuit we made earlier, and we can take these into an LED cluster, so we can light lights depending on which button we pushed, and that gives us an indicator. So yeah, I'm quite pleased with that. That should work. Let's give it a go. Okay, we're going to test the circuit. So what should happen is one should go up, one should go down. There should be 8 bits here. There we are. 1, 2, 3, 4, 5, 6, 7, 8. And then he's got their 8, and they all flash. 8, 7, 6, 5, 4, 3, 2, 1. But these are on all the time. So either I've made a slight mistake in the cascade, so it's no longer cascading from this chip to that chip, or I've got a bent pin or something. So I'll check that later. But in principle, the 16 bits are working, which is good. And and I just got to work out why the other one isn't working. Is it a chip error? Is it a wiring error? I mean, the wires look good and there's power coming out, but it's not cascading the input from the previous chip. So I just need to think about that. Okay, so it turned out it was just a little snot underneath touching one of the pins, and that was causing it to short. So now they should be counting up and down. Not all the LEDs are on the right hand side, but you can see them coming 6, 7, 8, 8, 7, 6, 5, 4, 3, and then I've got 2, 1 there because something's missing here. Run out of LEDs. Anyway, that seems to be working now. So very pleased with that. It's cool.